Now, without further ado, let's pass on the mic to Mike. All right.
Everyone hear me okay? Great. So hello everyone, great to hear all of your introductions. It sounds like this audience is working on a fantastic set of projects, so very interested to discuss all of these later. So I'm Mike Anderson, I'm the CTO at Covia. I'm here along with my co-founder Chadeep, and we're going to be talking about some of the emerging work we're doing on the Agentic grid. But just a quick reflection. I think I wrote my first neural network in 1997. I think it was on either a 486 or a Pentium computer was the thing back then, and of course it was only a toy. It didn't really do much, but it worked. It did some back propagation. You could train it. And now we're getting to this point where it's starting to become feasible that we can run a full workforce using agents. Not quite there yet, but we're getting very close. And what we're doing is building this universal grid which is going to help to make that possible. And I want to talk through a bit about the big ideas behind this. And of course, because I'm CTO, I don't talk about the business stuff, so I get to talk about all the fun big ideas behind what we're doing. So plan for today, I'm going to give a quick interview of what we're doing at Covia and what we're building with the grid. And then go into some of the concepts, how it works, and why some of these design decisions we're making. I would stress it's all still in development, by the way, and it is open source, so I do encourage people to get involved and come up with new ideas, because it will make it into the product if we collaborate on these things. And then I'm going to take a big risk and actually live code and show off how this works. And hopefully we'll be able to do some fun things and sort of show some of the capabilities that are sort of emerging in this space. And then I want to leave plenty of time for Q&A and discussion, because I think that's usually the most fun part of these kind of events. And if anyone does want to chip in during the presentation, feel free, by the way. It's always good to have a bit of interaction as we go through on these things. So, I guess our core belief is that the synthetic workforce is going to need a management layer. And this is going to require some quite special capabilities to make it operational. So why is this? It's not enough for agents to just produce answers like an LLM, chat responses. They've got to take actions. The problem with taking actions is you can do a lot of damage. How are you going to govern these? I'm sure you've all heard stories of, Claude deleting entire databases or committing major security flaws in your code. All kinds of bad things can happen. You need effective governance of that. But more importantly than that, how do you actually get these agents to work together, especially when they have to work across boundaries? If you're running a company using agents, they're going to have to collaborate with agents that are operated by other companies. You can't simply assume that you run every single agent inside your own environment. And this is one of the key differences between what we're doing and how a lot of agent platforms work. They assume that all of your agents are running in this sort of controlled space. In fact, the world is federated. Different people have different environments. So people going to be running agents on a self-sovereign basis, where you control your agent on your hardware with your data. And those agents need to work with the agents that are being run by the organizations that you collaborate with, or your business partners or your friends. And this requires some kind of coordination layer to make it happen. Another reason why we think this is a huge challenge is this environment rapidly becomes very complex as you talk about multiple agents, multiple interactions, multiple trust boundaries. And if you've done much work building LLMs, you probably have experienced the following story. It starts off doing wonderful work, but as you add more and more on top, it rapidly degrades. As soon as you start filling up the context window and it gets, too much in its head at one time, performance drops off very rapidly. And the dirty secret in with the model builders is that agents can only really effectively use about 25% of their context a lot of the time before you really see this deterioration. So in fact, managing context turns out to be one of the most important things for the performance of agents. And in a complex environment, of course, this context could be huge. It could be near infinite. You could have context from multiple different parties coming in. And also, you've got to control that context, because some of it may be sensitive. You can't just give them access to the entire world and the entire universe. And then finally, you have to think about problems like, how do you actually audit? How do you actually know what happened? What did the agent do? Why did it do it? And this is going to be increasingly important, and certainly in the EU, it's becoming a legal requirement in many cases that you can actually audit these things. So our belief, therefore, is that agents are going to need a coordination grid. And we think that this is going to be a natural evolution. And almost always, new paradigms ultimately end up needing some kind of grid or open standard on which they interoperate. And back in the dawn of the industrial era, when people first created power plants, electric power, there wasn't an electricity grid. People built their own electricity generators to run their factories. And it was only later that the grid evolved. But people were still building their own. They were designing their own generators. They were figuring out how to fuel them. And I'd say that in the agent space, we're sort of in that stage. We haven't got yet to the point where people have realized the need for some kind of coordination grid. So we believe we're early to this space, and we're sort of pushing forward the ideas of what's going to be possible. But all of these other examples, the network layer, TCP/IP, HTTP, card networks, you need an open protocol by which people can interoperate. And I think it's important that it's open. Yeah, you can't have this be controlled by a single party, otherwise it won't be universally accepted. So we very much work on the principle of open source and giving people control of their own systems, but letting them collaborate and coordinate across those boundaries. So we're developing this universal grid, and I just wanted to talk through a couple of key concepts. We call the nodes venues, so these are the places where things happen. And the grid is basically a network of venues, like a virtual overlay network. And the idea is very much that each venue can belong to a different person, a different organization, a different team. By default, you don't have any control over anyone else's venue, only your own, but you can grant access to other people so that the grid can actually work as a coordination layer. Within the venue, there's a number of different systems. We have our own agent harness, so you can run agents within the venue itself, or you can connect to other agent systems to utilize them with protocols like A2A. Bunch of tools, bunch of services, quite a powerful database system to manage all of the information as it goes through. And then it has adapters, and the adapters let you provide access from the agents to back-end systems, whether it's APIs or databases or any internal systems that you don't want to expose to the whole world, but you need to give your agents access to. And those internal systems may also have their own agents embedded within them. Yeah? So we've designed this to be totally flexible so people can configure it in the way that makes sense. So the grid, if you like, is the set of all venues and the protocol by which they communicate. The venue itself works as a layer that protects security, guarantees integrity, audits what happened, and provides a whole bunch of useful services. And then behind that, it's acting as a proxy to any internal systems that you want. And all of this can be configured, but the point is it provides authority, ordering of transactions and operations. It's got recovery, backup, resilience, the coordination capability across boundaries, and it provides a system of record. So you can sort of think of it as a system of record for agent interactions. Yeah? Not necessarily the source data, but for the interactions that agents take upon that source data. And it's federated by design, so this isn't owned by anyone. It's an open protocol, it's just a federation of all the people who choose to participate. And I think, again, this is an evolutionary concept. We started off with agents that you just chat to. The current thing that's happening probably mostly is container-based agents, where agents actually get something like a virtual machine and they execute commands. I'm sure if you've used OpenClaw or anything like that, they're basically running in a container and it's getting the ability to run shell scripts and the things inside a container. And they do ad hoc scripting, which is great and is very, very powerful, but it's also very dangerous and it's pretty unmanaged. And we think that the natural evolution then is to have this grid where we have a federation of venues, we have this universal addressability, and most importantly, we manage the capabilities of the agents so that they can't do anything dangerous without the appropriate authorization. And it's not just theory. We actually have this going live this week with an Agentic health app in the UK. So this is like a personal health agent, integrates to back-end systems, and we've actually got this working with NHS data, which is quite a feat because it's quite hard to get data out of the NHS. So this is the kind of system and product that you can build using Covia technology. And obviously we have many more in the pipeline. So I'm going to run through quickly a few of the concepts in the grid. I mean, there's a lot of things here, so I'm just going to try and keep it to a relatively high-level overview. But just to show some of the sort of design decisions and ideas that are important. So the first one that I think is really critical is the idea of identity. You can't have an interoperable system if you can't talk about the other things that you want to interact with, whether that's agents, people, data assets, etc. So we've sort of co-opted the DID standard. This is a W3C standard for identifiers. It's a pretty good standard, it's pretty flexible, but you sort of say, okay, this is a web type DID, there's a venue where someone's actually owning that domain name, means that they're the sort of authority over that venue. You can have a venue-specific user ID, but the trick of this, of course, is you can put a little path on the end to refer to specific assets and resources that a user or an agent has created. Now, with this system, you can address anything in the world. And agents, assets, data sets, systems. And this is what enables us to make the interoperability work by having these identifiers. It enables federation because each individual party controls the first part of the address, and the rest is then up to their discretion. I would say there's two types of DIDs that we use a lot. One is the web DID, where it's controlled by a domain. The second is what they call a DID key. And this is actually self-sovereign. You can create a cryptographic key yourself, and then you effectively have ownership of that DID forever. And only the person who has the secret key controls that. So you can run it on a fully decentralized, self-sovereign basis without having to rely on DNS as well. This just happens to be convenient for a lot of organizations. We have this model that everything is an asset, or everything can be considered as an asset with some metadata. We have a simple metadata standard that lets you specify things like data sets, models, so your models and your weights can be an asset, tools, operations, functions that you can run, and you can have agents, so agents with whatever authority you've granted them, and this metadata helps you define and manage these. It's pretty lightweight. One thing that's quite nice about it is that you can basically create a cryptographic hash of this metadata. You get a nice hash out of it, and then the metadata becomes content addressable and verifiable. So if someone says, this is my asset, or this is the metadata of my asset, you can check that. You can verify the hash, and you can prove that in fact that was the metadata of that operation, which becomes very important later on when we think about audit and being able to track back and prove what happened. You want to actually have these hashes in place. So then using this, we have this idea of a sort of structured context graph. So each venue provides a sort of map of context. In fact, for each user of each venue, there's a map of context. So, for example, you can have G stands for the agent namespace, and you can have an agent called Bob. And then all of the context related to Bob is sort of embedded within that. You could have an artifact, like a data asset with its metadata, and give it whatever path and name you want. I mentioned the hashes. Well, you can create an immutable snapshot of any data you like, put that in a content addressable store, and you can refer to it by hash. And that basically pins the reference to a particular version. So if you want to freeze an operation or an asset so that it's always done that way, you can refer to it with one of those hashes. And then we have some system internal things like jobs. So every operation that gets executed on the grid is given a job ID, and you can refer to that job. Again, this works for every user and across venues, so you can refer to other people's jobs if they give you access to them. And I think one of the things that's most critical is this idea of capabilities. And these are effectively the tokens which grant the ability of an agent to do something. So again, we like standards, so we've co-opted this standard called UCAN, which is a way of defining capabilities in quite a fine-grained way. So really you're saying that you can grant a specific type of operation on a particular kind of resource. So this, for example, is the ability to read a particular file. And it's been granted to a particular user with a particular DID key identity. So if you can prove that you are that user by signing a message, you would be able to use this token to access that file. And it's quite general purpose. You can pretty much design the operations and the resources as long as you've got the identifiers. And that's why it links back to the identifiers. You can identify something, and you can do that in a globally addressable way. Then you can issue these globally useful tokens to the people who you want to grant the rights to. And this provides the enforcement layer. Yeah, this enforces what agents can do. So you're not just letting them execute anything. They can try and execute what they like, but it'll fail if they don't have the required capability. And then critically, we create records whenever agents do everything via the system. So every single operation, every single job that flows through the system gets recorded. And we sign those. Yeah, so the venue is effectively acting as a signer, an audit of everything that venue has executed on behalf of its users. So in fact, it looks like a very big Merkle tree, all of the different operations that the agents have executed on that venue. We get a big Merkle tree and then sign that entire thing to make sure that we have an immutable record of exactly what's happened. So we're using basically cryptographic integrity to guarantee the state of the system and to provide auditability. So we obviously get a record of every agent action, who authorized it, and a timeline of things that happened. So you can always trace back. What I would say, and I just might flip back a couple of pages. This means that agents can actually introspect the entire system that they're running on, assuming they have the access rights. So agents can actually interrogate their own state, their own history, using tools and using this context graph, which is an unusually powerful capability. And I'm going to try and demo a bit of this just so that we get an idea of what's possible. Okay, so I'm just going to switch over to the console. I'm going to show you a couple of things that we use. I've got two things running here. Let me minimize that. I have our front end. We have a front end which is basically a sort of power user interface to a venue. And I've also got Claude code here. And Claude code is talking to the same venue via MCP.
Run this?
Oh, yeah, that'd be useful. speak into it as much as I can. So, yeah, so we have Claude Code talking to the same venue using MCP. So we're big adopters of the standards. We use MCP for lots of different things, but if I check my MCP setup, you'll see I've got a local Covia venue connected. All right. I'll just do a quick tour of the interface very quickly. So I've got a bunch of venues set up. So venue 1, venue 3. I'm using this one template test venue for the purpose of this, which is the one I've got running locally. There's a big list of all the jobs. Thousands of them, so you can see all the different jobs I've been experimenting with over the past few days. You get a job ID, you get a status, I could go in and inspect precisely what happened, etc., etc. So this is part of the audit log capability. I have a secret store, so my API keys are all stored in here. And notice I'm using multiple different providers, both to test it, but also to prove the concept that the grid is very agnostic to what underlying agent technology you use or what systems you interface to. So here I've got Anthropic, XAI, and OpenAI set up. I also have some agents. So I have an agent called Bob, and I have an agent called Poet. And I can create more, and we've got templates for different kinds of agents, and we're sort of exploring the different agent configurations that we get. So I'm just going to switch over to, one more thing I should just show is grid operations. So the venues come with this set of operations. They're like function calls, and they're very, very similar to MCP tools. In fact, some of them are MCP tools, but they work in a very similar way. So we have tools like set secret. If you wanted to set a secret, you can do that kind of thing. You can read a file. You can do some A-to-A integration, etc., etc. So you've got a host of these different tools available to agents, and they can actually produce their own operations as well. The reason we do this is to have basically whatever tool set agents need. We've got a comprehensive list, and when we build agents, we normally select a subset of these that we want the agents to use. So they can't just do anything, but they get a curated list of capabilities. So I'm just going to switch over to Claude, and I'm going to say, okay, ask Poet to write a poem. Topic? The grid. About the grid. Okay, so what's going to happen is, so this is already multi-agent system, yeah? So we have Claude talking to the grid, and Bob running in the grid, and hopefully us getting a response back from this poem. So it's taking a little bit of time. I can't remember what. I think I set it up on Claude Sonnet. I thought that was an appropriate one for the poet. Okay, there we are. What web invisible doth span the earth. So the poet is in fact configured to write Shakespearean verse, which I approve of as an Englishman. So that's the prompt and the agent setup, and the model is all doing it. The agent does not have access to its API key. All it knows is that it's got the key, because it's in the sequence store. It can't actually read it, but it then uses the LLM remotely, and this is all part of the agent state. Yeah. So if I can say, show me the poet's timeline. We should get a sensible summary of what's actually the poet has done. I think I asked it a couple of poems previously, so we should see more than one poem. And what's important here, I've not customized Claude at all. It is just looking at the grid and the tools available and the context graph that the grid makes available, and it's figuring out how to do this. Yeah? And this is absolutely key. Okay, so it's figured out the way that the context is structured, the way that the grid exposes the timeline, and created a sort of reasonably sensible summary of what the poet has done. So this is this concept of introspection. It's agents being able to see themselves and other agents and the progress of different operations that they're engaged in real time, and introspect these. Yeah, and they're long-lived agents as well, so that you can have these long-running tasks, working as a team. You can clone them. I can take an exact copy of, if I can say make a copy of Poet as an agent called Freddy. And again, Claude is just figuring this out from the tools and how to actually execute these things. So it's making some MCP calls. We'll have a new agent in a couple of seconds. Now, you don't actually need to ask an LLM to do that. Yeah, question. Sorry.
I just wanted to ask. So here you're obviously using Claude to trigger that agent.
Yep.
Do you see your grid as sitting separate to the kind of workflow or triggering of the agents, where the grid captures kind of the log, the history, the interaction, but your management triggering workflow engine would be kind of a separate concept management?
So typically you'd want to route them through the grid. It can be separate though, yeah? Because you want to route it through the grid so that you get the log and you get the enforcement of the capabilities.
Okay, so basically because you're running it through Claude, that's really much your MCP onto the grid, that's why you can be after the interaction, because you can have a separate workflow accessing like a Void agent application.
Yeah, you could totally have a separate workflow doing the same thing. It doesn't have to be Claude, by the way.
Yeah.
So so in fact, I can go here and I can talk. I could go and Freddie's our new poet. I can go and find Freddie and I can say, introduce yourself. And there's no Claude in the mix now. It's me just talking directly to Freddie, and there you are. He's introduced himself in a poem, yeah? But that it could be a front end, it could be a user chatting with the agent, it could be another agent like Claude sending a message, it could be a workflow tool where the workflow triggers an instruction to an agent, and you basically then configure the agent to receive the kind of message or instruction from the workflow that you're expecting. But that's a really good point, because as they're saying, that you give an agent too much context and too many tools, it gets confused. And I think this is one of the key reasons why the multi-agent case is really important. Because if you've got multi-agent, you can have a lot of agents with very, very specialized roles. And they'll be much more effective at that than a single agent which tries to do everything. So in fact, I think this is why you actually do want teams of agents, because one model often isn't going to perform well for all different kinds of tasks, and you probably end up having to use a very expensive model if you even try it, because just to have that many tools in context is often a problem. So this lets you assemble teams of agents very, very efficiently, and you could have 1,000 agents running on this no problem. Yeah, each with their own specialized prompts, and then you can give capabilities to maybe the more powerful agents that use more complicated models to manage some subset of those other agents. So you could have like team manager agents. But the lower level agents can use a cheaper model and just perform a very, very specific task. But then you can ask a powerful agent like, Claude Mythos or something to make organizational changes to your AI team. And this is how we're seeing the sort of evolution of the workforce happening. Yeah, you ultimately have agents managing these other agents on your behalf, and you'll just be providing the overall direction. I would say we're not running in a container here. This is our own agent harness in the venue, so it doesn't actually script or run anything dangerous. It's entirely sandboxed, which is a good default, I think, for these kind of agents that are going to have access to external systems and internal systems. Okay, so I mean, hopefully I've given you a bit of an idea of what the system can do and how you sort of interact with it. I'm happy to try anything. I can't guarantee it'll work because this is, demo, but if anyone wants me to experiment or try asking anything, then I'm happy to have a go, yeah?
I have a question. Was it an experiment?
Yeah, go for it. Yeah, sure.
So when you started your talk, you were talking about... Oh. Thanks, Mike. Impressive. When you started your talk, you mentioned, this as being potentially the platform or protocol of choice for agent-to-agent communication, not just within a environment, like within a company or one business, but across.
Yep.
How do you see that happening? Like, could this talk to an external Hermes bot, or could those things be augmented to support the protocol to potentially talk, or does everyone have to use your interface and application and framework in order to do it? Like, what would have to be true or what's the bare minimum of what would have to be true for this to catch on as a mechanism for inter-company agentic?
So the protocol's totally open. In fact, everything I've shown you today, by the way, is open source. You can download and play with it. Yeah. Anyone can implement the protocol. Yeah, and communicate using the API messages, we haven't done it yet, just purely for bandwidth, but teaching OpenClaw to talk Covia protocol probably wouldn't be very hard. Yeah, it's just an interesting project we haven't done yet. But you could make a lot of different systems talk to the grid, just like we've made Claude talk to the grid, because that happens to be very useful for testing and development. So almost anything could easily become a grid client and a user of the grid. Now, to actually implement the venue, which has got the state management and the capability management and the user management, that's a more complicated thing to replicate, but we've made that an open source core, so anyone can still run that. And then through that core, you can proxy through to back-end systems or internal agents. So it's designed to be a thin layer rather than a sort of full stack solution. You can think of it a bit like an enterprise service bus in that sense. So you can adopt it that way as well, just as a sort of ESB type layer, which is really just acting for routing the requests and governance, so controlling access rights and audit, and actually providing that management layer. So it can be adopted like piece by piece very easily. You can either just use it as a client, you could run a venue yourself if you want to have the sort of venue capabilities locally. You can use a venue as a proxy to whatever services you already have. So it's very important, we're not trying to replace anything in existing stacks really. You don't even have to use our agents. I mean, these agents, these poets are running on our own agent harness, but you don't have to. There's no requirement to use them.
Yeah, I think what your question was, right? So the thing is, you can bring your own agent, you can bring your own model. So we are not replacing anything.
So you have a built-in ability to create agents, but then you can also BYOA.
Yeah, bring your own agent, that's fine.
Okay,
yeah.
interesting.
And in fact, that's what the...
All right, that's an experiment. Can you bring your own agent right now and see if it works?
Oh dear, okay.
How long did that take?
Do I have another agent handy?
Chris can build it in under 2 hours.
Yeah, if you build one, I can get, because we have an agent. The thing is, it's got all the tools to talk to another agent. Yeah, so it can make out external MCP calls, A2A calls. It can do HTTP requests. So if you have an agent sitting behind an API, it can just call those. So you would actually get good integration just simply using an HTTP call. And then from the grid perspective, you give that then some metadata. You can say, hey, this agent is available on the grid with this access right. Other people can call via the grid to your venue, and then it just proxies straight through to your agent, whatever you've built, with whatever stack, and with whatever back-end technology you want. So it's quite easy to adopt that way. There's no real complexity in doing that. And you could vibe code that in half an hour probably.
Cool. Hi, so bunch of questions, a couple of them around tech, one around business. So one of the things that I see, and to give some context, I was working in my previous company to build like a purple ID. We use Polygon ID to have a zero knowledge proof based sort of an identity layer. The decentralized identifier that you are using for agents, it's sort of a very strong natural complement to what a blockchain or distributed ledger sort of provides. So I want to understand like the thinking behind the design decision to not go with something like an L2, L3 to have that identity layer put on a blockchain and go through like this DID route. The second question is that in terms of the auditability and the hash being generated on the Merkle tree, so who does the responsibility lie on to maintain that sort of log? Like let's say there are multiple organizations and org1's agents is calling org2. So where does that auditability layer lie and whose responsibility is it to maintain and share that? The third question would be like, so I was building a sort of a similar protocol for multiple hospitals in India. So they had like this agentic suite where hospital A could trigger hospital B's agentic suite and like access their data and do some patient data transfer. The problem we ran into was not tech, but the bureaucracy where they were like, hey, why should I share my data? Like you could poach my patients and so on. So how do you go on solving that particular per se? And last question, like for business, where is the money to be made in this? Like who pays and why do they pay for this?
Yeah. Okay, so I think I've got 4 questions there, so let me try and tackle them. So you mentioned crypto, that's kind of interesting. So I didn't say this in our intro, but Churdeep and I were both fairly instrumental in Ocean Protocol. I don't know if you've heard of it.
Yeah.
So Churdeep was one of the co-founders and I was CTO. So we've been through the whole crypto space. And one of the observations was that blockchains are not actually the right place to do this kind of good stuff. Yeah, especially not public blockchains, but they're just sort of the wrong technology. They've got a lot of limitations. If you use a public chain with tokens, it gets very expensive, and the performance is just totally unacceptable. Yeah, for this kind of stuff. This thing can do hundreds of thousands of transactions per second. Yeah, easily. Yeah, it's very, very fast. And I actually spent 5 years building a new kind of decentralized network technology. Called Convex. And this is actually the sort of data structure engine behind Covia. Now this, you can think of it as sort of a supercharged Merkle tree engine, but it's extremely fast. It can do like millions of operations per second. It's a bit of a superpower. And that's how we can build some of these context capabilities on top. Now, everything in Convex works as a big Merkle tree or Merkle DAG. And it's very easy to replicate them. So it works like a conflict-free replicated data type, which comes on to your second question a bit, think about auditability. What you do is you have each venue signs its own section of the tree. Yeah? You can then replicate that to others, but still with a signature. So they can verify that audit trail and a signature, but they can't change it because they can't obviously re-sign it with that key. So this can actually be run as a peer-to-peer conflict-free replicated data type. It replicates very smoothly, you don't get conflicts, and it provides like a global audit capability. Now normally you would audit your own stuff, but the capability is there in the substrate. If you wanted to share your part of the tree and share that full Merkle tree graph, you can. Yeah, which is actually quite an interesting capability. We see that more likely being used when you've got multiple venues within the same organization and you want to have one point that aggregates all of the audits from all of the individual venues, so they've got an integrated view, but it's still signed, and you've still got the cryptographic integrity. So that's the sort of key point there. On the identifier point, we actually do support convex DIDs as well. I mean, I didn't talk about it because it's not the topic of this thing, but you can actually put a DID on the public convex chain if you want. We generally find that you don't need it for peer-to-peer self-sovereign use cases where you can just generate your own key. So DID key works perfectly fine for self-sovereign use. And organizations are probably going to want something like a domain name authority with DID web. But we do have that option available if people want it. So yeah, we've got three kinds of DIDs in operation. That was two questions, I think. You asked about the hospital infrastructure. Sorry, could you just repeat that part? How did the organizational...
It's like, organizations unwilling to share or sort of let access to anyone, external agents, a party into their system of records and data. That's a major challenge that we have faced,
Right, so this is actually one of... This is one of the key reasons why we think the grid has to be federated. Because we think you can't tell organizations how to manage their data or their systems very easily. And if you try, you end up getting locked up in bureaucracy and the arguments go on forever and the risk, and many organizations are legally prevented from doing certain things, and you're just going to spend all your time with lawyers. So the whole point of federation is to let each organization do it how you want. You choose your own rules in your organization, and you choose which capabilities you want other people's agents to be able to access. So we give organizations the ability to manage that, and then you can have a network of organizations working together, but each in control of their own domain. And I think that's the solution. You give them a way that they can keep control of what they quite reasonably often feel that they need to have control over. And that's what federation buys you ultimately. And we think that's what makes this very distinctive from let's say one of the big providers wants to provide some kind of agent service. You're always going to be then locked into that provider if you build all your infrastructure on that. This lets you keep control of your infrastructure, your data, your back-end systems, and how you want to provide access to it. So that's the organizational question. And then the final question was about money. So I say we're a relatively new startup. I think the two primary ways we'll be making our money out on this. First of all, we'll be offering hosted services. So these venues, you can run them yourself, but it's far easier just to press a button and get a venue run for you on the cloud. So hosted services with sort of pay-as-you-go billing is absolutely a business model. And then the other model is like a Red Hat model. So we provide professional open source, we provide an open source core, but we also provide enterprise adapters, configuration and services related to that. Which is what you need if you're going to deploy this kind of thing in an enterprise. Yeah, they're not going to use a hosted service. They've got a lot of constraints. They have a lot of IT requirements. They all want to manage the systems in their own environments, but they then need the support and the services to help that. So our model is to work with partners to do that. So partners can then, maybe system integrators who already work with a lot of enterprises can take out this tech and then deploy it to help solve real problems in the enterprise and give them like this kind of agent capability that they're all realizing they need but don't quite yet know how to do. Yeah, and that's what Covia is ultimately. Our business model is about that.
Hi, thank you for that really interesting presentation. I think it's really exciting because it maps to this real pain that I've had with my agent ops. So sometimes they always say done if you have tried overclaw, but then you have to ask them can you show me the commit hash? And sometimes they say, oops, I realize I haven't done that, right? So you have really solved a real pain point that I'm seeing. And I think one thing I wanted to ask is that natural language retrieval through Claude, which is what you showed us, is really powerful. But for governance, if I weren't going to access the logs through LLMs, right? I noticed that the Covia docs actually said that you expose REST API access, and then you have endpoints for status, assets, operation jobs, etc. Can you show what the non-LLM operator interface looks like? If I want to query.
Yeah, let me just. Yeah. So this is actually the venue has a little placeholder web page, which I normally don't show people, but this just proves that the venue is actually running. And this is actually hosting a bunch of, oh, that's the wrong Swagger. I've not set it up right. I'm actually getting the convex Swagger here. But you can see the Swagger API, and then you can make everything that the agent can do, so everything that Claude was doing there, you can do in code, deterministically, with no LLM involved. You can ask for a job status, you can submit a job, you can make a request to an agent, you can read something from the user's data. Again, and it's all exactly the same enforcement, yet it all goes through the same capability enforcement. So it's exactly the same, you just program against it as an API.
Okay, great. So it's kind of having access to SQL commands on supervised place.
Yeah.
Yeah, that's great.
Yeah.
Thank you.
You can sort of think of the venue as containing a little sort of database engine in its own right, but it's a sort of a context and agentic database rather than an SQL database, but it works in the same way.
Nice.
Yeah.
Just out of curiosity, do you have a model preparation? If someone brings their own model, this is their technical MCC server. What if the model has the ability to traverse that space? What is up to your standard? And it starts doing things that are kind of off. How do you mitigate that?
What we actually do is we set up more limited agents. So there's no reason, but you don't actually have to use a tool calling model here, You can actually just use an agent that does a standard response and can't call any tools whatsoever. And then, you can give it then a very tailored system prompt to do what you want. The other thing that we found quite effective is, I showed those capabilities and the UCAN. Well, the agent actually sees their capabilities. And the tools that you give it and the capabilities that you grant oddly seem to be quite useful context. Because if you've given the agent the ability to write to a particular space, it sort of gets the hint that that's what you want it to do. Or a particular file or something like that. So by carefully curating the tools that the agent gets or the capabilities that you give to it, it sort of gets the message, and it can perform with even quite limited models. I mean, we're still experimenting a bit with different models and how well they work and how to prompt them most effectively. And that's, by the way, a never-ending task, because every time the models change, you have to recalibrate your system prompts. So we sort of tend to be just a little conservative at the moment. We probably don't need Sonnet to write a poem. But we just give it a little bit more model power than it needs usually.
Thank you.
I love the concept. I think it can be used for compliance. At the same time, I'm also worried because you're essentially giving the keys to to bypass a lot of layers, essentially. So, and I also think that if, let's say, I'm not sure how it works fully, but then if the agent is given a bunch of MCP potential tools to use, and then it might instantly know that, hey, you can do this, and it might go rogue.
Sorry, I didn't quite hear the last part of the question.
Question, and additionally, because you're sending natural language into your agents in the first place, you could also inject something into that agent that then could expose more capability to the agent that you have within your grid.
Yeah. So the point I'm trying to make on, which is also adding to hers, is there maybe there could be a progressive exposure of tools such that you could. Is it? Did you have it?
Yeah, absolutely.
Okay.
That's what we normally try and do. So I found that there's usually two use cases. One, you want an agent that has a broad set of tools so that it can act as a problem solver or project manager or helping you debug stuff. So Claude, I've given like the full set of tools, yeah? When you actually want an agent that's performing a particular task, you want to give it very narrow tools and very narrow capability grants. Yeah, so it literally cannot do anything you don't want it to do. And that's to your point of compliance. You can actually just go and audit all the agents and say, what can each of these agents do, by looking at what capabilities they've been granted. And generally, it's good practice to keep those capabilities pretty narrow for production agents. In development, you can be more relaxed, but for production, you want to narrow that down so that the agents can't do anything dangerous. Now, the other thing you can do, of course, is you can say, well, agent can do it, but it's got to ask a human for permission first. So we can enforce human in the loop sort of requests. And again, that will be logged, yeah. So, which was the authorized signed-in user who approved a particular request for an agent to have some kind of action outside its normal capabilities.
But is there then controls around the data that's being exchanged between agents? So, kind of like, so obviously you give all the controls to say you can only do these things. These are the skills you have allowed access for. But then how do you make sure that you're not prompt injecting or anything into that agent that then can take malicious actions?
Yeah. So again, it's the same principle. You narrow the scope as much as you possibly can. Yeah. So the agent really, typically you want it to be able to see two things. The input of the instruction it was given, so what was the request, and then some subset of this context. Yeah? Maybe all of it, if you want something to do it, want to do some diagnostics. But more likely, you might say you can only read project 1. Yeah, and then the agent is not going to be able to go and read project 2 because it's had its capabilities scoped to that particular area of data. So the agents can collaborate on this shared context, but only if you give them the rights to do so. So this acts as kind of like a shared memory layer or persistent memory layer that the agents can collaborate on.
I guess another way to ask that question, I'm wondering, is it that if you move in a situation where you do model injection and you give a lot more context, even if the agent is blocked from performing the action, is there any risk of having an agent, even though it gets blocked from performing an action, but having that context, is there any risk there?
So there's an information extraction risk depending on what tools the agent has. Yeah. So if the agent's able to make external calls, then it could leak information to an external system.
Could you limit that as well? In terms of networks?
Yeah. You can say you can't do any external operations or HTTP requests or something like that. Yeah.
I think you could audit how many times context come in where an action has been requested, but it got denied, and that'd be part of your audit as well, right?
Yes, can be, yeah. So typically there's some configurability around this. Typically we found the most useful thing to audit are the operations. Yeah. So what did an agent actually do, and what was the result? Right. Yeah, and that gives you kind of a complete timeline. Now, if it asks for a big chunk of context, you can't always tell whether it used any particular part of that context, but you could tell that it requested it or it put a request in. So you could audit that. Fine-grained stuff, I mean, that's also possible, but we turn off some of that because otherwise your logs just go.
Maybe another thing to add in terms of what you were asking is that even operations can actually be quite narrowed down. So what operations they have access to, what operations they can actually operate essentially, irrespective of what they're being given access to. So that also kind of narrows down quite a lot, and that we've seen is actually not something that others really offer.
Yeah. I mean, the closest thing is if you use Claude and, if you go on the always ask for permissions, but you have this like long list of bash commands that you're letting it do. The problem with bash commands is very easy to work around them and, exploit some bug or loophole to get out of this. So whereas we prefer to have the operations defined at a more specific action level, like set a secret or make an HTTP request, that kind of level, so that we're very, very specific about what the action means from a business and technical meaning. Yeah, and that could be send an email to a user or something like that. You want to align the operations that you give your agents with the kind of actions that you want to grant them or govern, and that appears to be the best model at the moment, rather than giving them full shell access. I do too, but I always feel bad about it.
We did want something to try and break the demo. Something that you can just put there.
I'm sure you can break it.
So one thing, in this sort of multi-agentic systems, one of the things that we have observed here, realize, like let's say there are 3-4 agents working together. The moment agent 1 makes a mistake, even if it's like 1 in 100, but by the time it reaches like 4th, 5th agents, it sort of compounds very quickly and performance degrades drastically. So what I'm trying to think of in terms of evaluations as to which agent did what mistake, and in terms of this sort of auditability, how are those two layers connected? Like this is sort of the logging what the agent is doing, but what it's doing, is it right or not? Like that's sort of the evals layer problem statement.
Yeah.
So how do those two connect together?
So this is where we would take advantage of the grid introspection. Yeah. So if you imagine if things go through the happy path and you evaluate that in fact this is a relatively safe happy path and it's all gone smoothly, fine. You don't need to do anything. But if you have a detection system that picks up an exception, like something went weird, one of the tasks you expected to work failed, one of the agents reported, threw its hand up and didn't complete its task or whatever, then you would want to make that back out and raise an exception to a more powerful agent, which can then diagnose. Now, because you've got the grid, that agent can introspect exactly what happened in that chain and self-diagnose the process, and possibly even correct the process, so that it doesn't happen again, and fix it. And this is actually one of the beautiful things about this ability to have this context like this, is a more powerful agent can come in and fix things. Yeah. So actually, I just use Claude to diagnose what other agents are doing and give me reports, and I find that the easiest way to actually work with the system. But you can absolutely do that operationally in a real business process if you set up an agent to catch exceptions and raise exceptions to that agent, which is coming to the point about it's a real workforce. Yeah. In a real workforce, you do your job, and occasionally you can't proceed because you're blocked by something, so you have to raise an issue. And we would imagine agents being sort of configured in a sort of similar kind of way.
I'm just thinking about the complexity of putting this into an enterprise. Like just managing one agent, like project one, my asset, is like a huge headache for me. And then imagine like multi-department, which asset, which agent, and then you have thousands of agents, you have opus, and then you have the small agents. How do you think about this from an enterprise adoption point of view? Small projects scale up gradually, or is it like a multiple opus trying to help you? How do you think about it?
I mean, this is designed to be very scalable. But the main problem is limiting the context that any one agent sees, because they obviously can only handle a certain amount. This is why this hierarchical structure of these paths is really important. So typically an agent is never going to be seeing everything at once. It's only going to see a particular part of the path or a particular subset. If you do give it the whole thing, though, it actually does surprisingly well. And the reason it does surprisingly well is this just looks like a directory structure or a JSON object structure. And models are actually quite well trained on those. And they know how to navigate them, and particularly to list and how to summarize, how to sort of guess where in the tree they should go down to explore and find the things that they want. So we haven't found that a problem so far for agents being able to navigate quite a bit of context here, providing they're properly prompted and providing you tell them which bit of it that, what problem you want them to solve. We have a couple of other ways of managing this, of course. So as I say, you can have multiple venues. Multiple venues can actually containerize that, particularly if you've got teams working on particular things. Agents can, by the way, request something from another user or another venue. They just probably don't have permissions by default to do it. So by default, an agent, you can give permissions to yourself, but not to other organizations or other users. But you can containerize it like that. And the actual underlying lattice storage is designed to be more or less infinitely scalable, so you can have as many objects in as you want, providing you've got pointers into it and paths into it.
I mean, just to add, I think you were also trying to say, how can, in a large enterprise, how exactly do we manage given the complexities that are involved? So I think it kind of goes back to you start with one venue, you start with what, your boundary really is, whether it's one team with 20 agents and then you kind of expand from that. That is where the concept of venues really helps a lot. So I think you were more, if that was what your question was about the complexity of what it is, you can't that is where venues help quite a lot.
Yeah, exactly. And, it's hopefully something that is quite easy to try out in the small, but then extend and add to. There would probably be some complexity if you wanted to rearrange things. So imagine you had a bunch of projects in one venue and you decided, in fact, you wanted to restructure all your projects and move some of those projects to a different venue or a different company. The only thing there is you would have to go and probably tell the agents that, hey, it's moved. And they would understand it, I think, but you might get a bit of confusion in the renaming because they'd be still, if they're written references to an old location. So, probably we say try not to reorganize these trees too much because it'll just cause you a lot of token cost churning it, but it would work.
Like, who do you envision to be the people who's managing this? Is it like an entire department of a new kind of skill? Like humans, who is it? Like, is it IT? Is it the department heads? Like, I cannot, like, if you let me manage this, I will screw it up so bad. So, like,
Yeah, we're not quite there yet. But what would we imagine is there's like an agent sort of control pane. A little bit like this interface, but probably more tailored for management people rather than techies, where it'll show you your workforce, the different roles, what they're, and basically give you the ability to prompt for changes or activities in the workforce. But then it just ticks over, and they'll be carrying out their tasks. And I'd see this as augmenting departments. So let's say a department has a lot of a certain routine kind of task. It would say, okay, create me a team of 10 specialized agents dealing with these kind of requests on an ongoing basis, and then you maybe vibe code the email scraper that takes a certain kind of emails and sends it to these agents to process. That's the kind of way I'd imagine people using it initially. And that doesn't have to be a technical person necessarily managing that, but you would probably, obviously at the moment, you would absolutely want a technical person checking the security and the setup so you're not doing anything dangerous. Yeah.
Yeah, there's a reason why we call it a synthetic workforce. We in fact will also have an operation where an agent actually gives a human a task. So, it is really that, in that sense, a synthetic workforce that you have and they have a human workforce too.
Tony and I have been talking about this. I love your answer, by the way, about the panel provided up to the decision makers or to the management level. We've been talking about this idea where, so in this context, you have the agents, the operations, the capabilities, and the tools, right? And we were thinking of, what if you had a layer where it's actually the management defines the objectives? And now with the objectives, that view is a lot more relevant for them. And then you can traverse this with like a multi-objective optimization problem where you have all these different agents, and they're fulfilling these objectives that basically map the organization's different departments together. Is that, I think that view, is that something you're going to build? Where it's not just the agents, the capabilities, right? There's the prescription layer.
Yeah, I would absolutely imagine that being a normal way of operating. Like so you've got that W data stuff. Yeah, I could easily say you're having a W organization, and have agents build a map of your organization and its objectives and its teams, so that the agents, in fact, if they need to talk to a human, they actually know who's in the organization, who they contact, who they escalate an issue to.
And I love this idea where now at that point humans and AI can truly collaborate together for that common objective, right?
Exactly.
Is that something you wanted to build into open source? I'm curious.
Well, we haven't built it yet, but we will probably make the core open source. Whether we make all of the management tools and that is still open for the decision. But very happy, by the way, to collaborate on a lot of this stuff, because this is a very, very powerful underlying substrate. But there's a lot to do building the interfaces and the agents that run on top of it, and also the integration through to useful back-end systems. We've built a few, but there's a lot more we could do there.
My gut tells me that probably be the best way for enterprise adoption, where you have the venue and the objective.
Yep.
Last one, maybe last one, and then we will.
All right, so it looks like you're attacking some pretty big, problems with targeted solutions like federated data, bring your own agents, tap it into the APIs, build in a lightweight interface and even ability to create agents from within it and some templates. So you're doing a lot of things to already kind of address a lot of the problems that enterprises have, auditing everything. What do you see so far in your work with businesses who are potentially going to do a pilot or to work within this? What has been the biggest barrier for adoption that you've seen so far that you haven't tackled yet in your current solution?
We're quite early days, I'd say. So we've had conversations with a lot of different organizations. I mean, quite a lot of organizations aren't yet at the point that they realize they need this. Yeah. So quite a lot of people are still at the stage where they're only experimenting with LLMs, or they're using it as a chatbot, or they maybe have built a little agentic system that takes certain kinds of documents and summarizes them, or performs something like that. They've not really got into the multi-agent collaboration kind of topics yet. We get, and obviously this is an emerging field, and they don't quite know, there's a lot of confusion in the space about what might be possible and what will be possible, etc. So I think the challenge is, I think, education on this stuff quite often.
Yeah.
If I may add, I think it's just in terms of, we are super early. But what we're also seeing is that there are certain companies that have been kind of building this kind of a substrate only for their application with 4 or 5 agents, and they've been re-architecting it again and again. And just because they've raised a few hundred million, and they're actually focused on a very narrow use case, they're able to do that. But they know that as soon as they add more agents, they're having to kind of refactor the entire thing. Yeah. So that's the other observation we've seen. And I think a lot of these kind of applications are still stuck in pilots rather than going to production for exactly the kind of problems that Mike suggested.
Yeah. It can scale from a technical standpoint faster than it can scale from an operational standpoint.
Well, it has its own problems.
Yeah, I think the challenge is a lot of it's about building in a silo. Most people are still at the stage where they're building a very specific solution for a very specific thing, and they haven't yet grappled with the problem of connecting across all of that. And this technology really comes into its own when it's federated and it's spanning across boundaries.
All right, round of applause to Mike and Shirley for spending the day. Feel free to hang around. We close at 6. You can work here, you can work there, you can just hang out. All right, thank you so much. You can connect.
Thank you, everyone. Great questions.
Thank
I actually have a question. So the assumption is the enterprise will have lots of agents.
Yep.
Because my friends believe it's going to be either just Gemini agents or OpenAI agents in SMBs. At least that's what we see. So how? Because there's other agents, but it's sub agents from Gemini. It's not going to be Opus, Gemini. We kind of don't see that. What's your assumption?
It's an interesting question. Obviously lots of people are going to be building lots of different agents in different ways. I'd like to give them an open source, solid option.
Of course, that's good, but that's really good for advanced users, right? Like Michael mentioned. But I think the assumption that we have, do you see differently?
I would say probably that for basic stuff, people are going to go to one of the big providers platforms. I think it's when it gets more complicated, or when they have their own internal systems. Then if you're simply getting an agent to do a job and you're going to just interact with it on the browser, then you don't need this stuff. But if you have to do audit logs, if you have to access your own back-end database, if you have to span across multiple agents, then this stuff becomes important. And I think one of the things that's very interesting is a surprising number of people are adopting things like OpenClaw. Trying out these systems. And OpenClaw is quite a heavily weight system. And this is lighter than OpenClaw. So I think if small businesses are willing to use things like OpenClaw, they'll easily be able to run something like this.
I think there's a different angle